Welcome to DSRT 734 class, Inferential Statistics in Decision Making. In these lectures, we're going to discuss about experimental design. So our main objective is to design a start studies, also discuss data collection techniques, discuss how to design an experiment, and also discuss the sampling techniques. So designing a start studies, the first step or the first stage is to identify the variables of interest. That is the focus, and also the population of the study. So first thing we should do again, the variables of interest. For example, if we want to study if environment A causes a specific outcome, then we need to study the environment variables, and we have to focus on that. And in every studies, again, our main goal is about population. So first, we need also to discuss about the population. So let's say example for population will be, we want to do a studies on a male age between 20 to 40. So again, first step, identify the variables of interest, that's the focus, and also the population of the studies. Now after that, the next step is to develop a detailed plan for collecting data. And if you use a sample, make sure the sample is representative of the population. What we mean by representative of the population, it means to avoid the bias in our sample. A very simple example is if a Democrat passes a law or a bill, or they want to pass a bill in the House, let's say Senate House or House of Rep. Again, we have this bill and we want to take a survey how the public react to the bill. Well, we are not going to focus in an area that we know is a blue state, or an area that we know 90% of the population are, again, Democrats, or an area that we know 90% of the population are Republican. In this case, if we collect the data, there will be a big bias. There's a bias in the data. So we want to go to a place where the chance is almost 50-50 that we have 50% Democrat, 50% Republican. And this may again help us to at least reduce, if we cannot eliminate, the bias in our data collection, the sample. So again, first step, identify the variables of interest, that's the focus. Now the second step, we develop a detailed plan for collecting our data. Then after that, we collect our data. In the data collection, again, we may discuss about this in detail. There are so many techniques in collecting data. And the most common one can be taking a survey. Another process even can be an experiment. We can do an experiment in the lab, and in the process of the experiment, we collect our data. The next step is to describe the data using descriptive statistics and techniques. Now, the main goal why we are going to describe the data is for us to understand our data, and the attributes or the variables, and the values between the minimum, the maximum value. Let's say if it's a blood pressure of a person, a population or a sample, we want to know the average blood pressure for the whole population or the sample we collected, then individual, etc. So after that, we understand our data. We are going to interpret the data and make decisions about the population using inferential statistics. So again, the first step, identify the variables of interest. The second step, we say we should develop a detailed plan for collecting data. Then the third step, we are going to collect the data. Now we have the data now, so what we need to do, we want to study the data. We want to understand the data, so we describe the data using the descriptive statistics techniques. Then we need to interpret the data and then make a decision about the population using inferential statistics. As we mentioned in lecture number 1, The main two areas of statistics is descriptive and also inferential. Descriptive, the main goal is to summarize our data, understand the data, exploration of the data, to explore the data. Inferential statistics that's when we use a sample to test our data. The data we have, again, is a sample. We use the techniques to, again, study the data, then make a decision on that data, and that decision will be generalized to the whole population. Now we identify any possible errors, which is very important. Every experiment or studies, most likely we may have some errors. So first we talk about data collection. So the first techniques of data collection can be observational study. Here, a researcher will observe and also measure the characteristics of interest of part of the population. Then researchers can observe and also record the mounting behavior on non-food objects of children up to 3 years old. So this again example, and this source is from Pediatric Magazine. So researchers observed and also recorded the mouthing behavior on non-food objects of children up to 3 years old. And the next is the experiment. Here we see experiment is a treatment is applied to part of a population and the responses are observed. Experiment is very good in the sense that it removes confounding variables and it's more help us to know the causa. So here we are going to have some intervention or a treatment maybe applied to a population, and what is the response? So example here is an experiment was performed in which diabetes took cinnamon extract daily while a control group took none. So this will be a case study concept. We have the case and we have the control group. So case control studies. The case will be the actual subjects that take the treatment or the intervention that we are studying. Then we may have the control group. Control group are those who didn't take the intervention or the experiment, whatever drugs we are trying. So here we say after 40 days, the diabetes who had the cinnamon reduced their risk of heart disease while the control group experienced no change. So here we can, to an experiment again, we can say that the treatment or the intervention was ineffective if it reduced the risk of heart disease, while the placebo, which we call the control group, didn't experiment any change. Another way of collecting data is using simulation. So uses a mathematical or physical model to reproduce the condition of a situation or a process. This often involves the use of computer simulation systems. And during this simulation again, we are going to generate data. So example is automobile manufacturers use simulation with dummies to study the effect of crashes on humans. Survey, which is one of the common techniques. This is again an investigation of one or more characteristics of a population. This is commonly done by interview. Most of the time now, because of internet, is by email. But traditionally, it's been by interview or mail or telephone. But now, internet or email is one of the common techniques. And sometimes also we can take a survey by developing the application. There are so many, again, web applications for surveying online. So a survey is conducted on a sample of female physicians to determine whether the primary reason for their career choice is financial stability. So this will be a survey. Again, go to the field. We interview female doctors, and based on the question, we have two types of questions. We can have the formal questions, which have a direct result, yes or no, true or false. And also we may have an informal question or open-ended questions, which is based on reasoning also. Reasoning. So example is given here, methods of data collection. They say we should consider the following STAT studies. These STAT studies, which method of data collection will you use to collect data for each of these studies? So the first, they say study of the effect of changing flight patterns on a number of airplane accidents. So the study of the effect of changing flight patterns on a number of airplane accidents. Simulation will be the best way because again, this is involve accident. We don't want a rare accident to happen and collect our data. We can't do survey on this. So the correct will be simulation. And that's what they mean. It is impractical to create this situation. We don't want to create an airplane accident situation. And maybe a life will be lost, people may die, or even the airplane can be destroyed. And we know the price. Airplane is very expensive. So simulation will be the best tool to use. A study of the effect of changing flight patterns on number of airplane accidents. I want to collect the data. The best way to collect this data is by simulation. We should simulate the airplane accident condition. Then based on the simulation, we may collect our data. Also, the study of the effect of eating oatmeal on lowering blood pressure. Now, the study of the effect of eating oatmeal. We know oatmeal is not very harmful, not even very, it's not harmful to drink. So simulation we don't need simulation in this case. So here we say experiment. We measure the effect of treatment when you eat oatmeal, eating oatmeal. Again, accident is very harmful, so we need a simulation. We don't want to use a rare person. By eating oatmeal, it's not dangerous. It's not life-threatening. So we can actually perform the experiment giving oatmeal to a person, not a dummy. So a study of how fourth grade students solve a puzzle. And here we say observational studies. We're going to observe the student and see how he solved it. Observe and measure the certain characteristics of part of the population. The study of U.S. residents approval rate of U.S. president. So the study of U.S. residents approval rate of the U.S. president. This will be a survey. Now, next we go to the key element of experimental design. There are three major key elements. The control, randomization, and replication is very important to replicate something. Because we want to, if we are doing one experiment, if we repeat the same experiment 10 times, we are expected to get the same result 10 times. And this is a very good to replication, is very good to test the experiment. And again, to test the valid of the result also. So control for effect other than one that is being measured. So example will be a confounding variable. Confounding variable is a big issue here. This occurs when an experiment cannot tell, the experimenter cannot tell the difference between the effect of different factors on a variable. So a confounding variable will be a third variable that may have association with the outcome or the dependent variable, but it doesn't have a causal relationship. So an example would be, let's say, in the desert of Arizona. During the summertime, snakes normally come out from their hidden places, habitates. They come out and they end up going to residence, building, apartment, and biting. So this means in the summertime, snake bite is very high in Arizona desert. But at the same time, ice cream sales also are very high. Now, we cannot say there's a relationship between ice cream and snake bite, but there's another variable that is causing the two to have an association, but there's no any causal relation. In this case, it will be the weather. So confounding variable is very good to identify and possibly eliminate it, but most of the time, we cannot eliminate it. Our goal is to reduce it. We also have what we call the modification effect. Modification effect is the same concept of confounding variable, but as we said earlier, confounding variable, we are going to remove it. Our goal is to even to eliminate it from our studies because it's false association. There's association between two variables, but there's no causal association. There's no causal direct. But we have another modification effect means it can be increased or decreased. So let's say again, when you smoke cigarette, you get lung cancer. Modification effect will come like normally most of us don't smoke cigarette unless we drink coffee. So the more coffee we drink, the more cigarette we smoke. And that will increase the lung cancer, chance of getting lung cancer. Now, with this, we cannot say there's a relationship between drinking coffee and lung cancer because when I drink more coffee, I'll get a lung cancer. No. It's just that when you drink more coffee, you are going to take more cigarette, and that can lead to lung cancer. So a modification effect is very important. We want to know it. That will help us a lot to determine our main objective, which is the outcome of the studies. But this is a negative modification effect. There's a third variable that will cause the outcome to happen very quick. Now, if I'm smoking and also I have a drugs that I'm taking which clean my lungs, most likely I may not have a lung cancer. So if there's no lung cancer, we can say, no, there's a third variable. Smoking causes lung cancer, but this time I'm smoking and there's no lung cancer. So this, again, can lead us to what we call modification effect. The main issue here, again, is not the smoking, but it's the drugs that I take that cleans my lungs for me, which make me to smoke more cigarette, but I don't have no lung cancer. And also placebo effect. Here we say subject react favorable to a placebo effect when in fact he or she has given no medical treatment at all. And binding also is a technique where the subject does not know whether he or she is receiving a treatment or a placebo. A binding is, we have what we call the double binding. Double binding means the person taking the medicine doesn't know it's a placebo. And also the person that administered the medicine doesn't know whether it's placebo or the real drug. So that is double binding. Single binding means the person receiving the drug doesn't know, but the person administering it or giving it out knows. So binding again is a technique where the subject does not know whether he or she is receiving a treatment or not. Then double blinding, as we said earlier, double blinding experiment is neither the subject nor the experimenter knows if the subject is receiving a treatment or a placebo. So double blinding again means the doctor doesn't know, the patient doesn't know if they are getting actual drug or they are not getting the drug. So next will be the randomization. We talk a lot about this. So here we say it's a process of randomly assigning subject to a different treatment group. Completely randomized design, here we say the subjects are assigned to different treatment groups through random selection. And then randomized block design, here we say we divide subjects with similar characteristics into blocks. And then within each block, we randomly assign subject to treatment programs. So this is an example. Here we say an experimental testing the effect of a new weight loss drink may first divide a subject into age categories. Then within each age group, we randomly assign subject to either the treatment or the control group. So we also have the match pairs design. Here we say the subjects are paired up according to similarity. Then one subject in the pair is randomly selected to receive one treatment while the other subject receive a different treatment. And replicate, as we said earlier, to replicate means to produce something over. So replication is the repetition of an experiment using a large group of services or large group of subjects. Example here, to test a vaccine against a strain of influenza, 10,000 people are given the vaccine and another 10,000 are given a placebo. Because of the sample size, again, because of the sample size, the effectiveness of the vaccine will most likely be observed. Now, a company wants to test the effectiveness of a new gum developed to help people quit smoking. Identify a potential problem with a given experimental design and suggest a way to implement it. So here we say the company identifies 1,000 adults who are heavy smokers. These subjects are divided into blocks according to gender. Then after 2 months, the female group has a significant number of subjects who have quit smoking. So the group are not similar, but the new gum may have greater effect on women than again in men, or vice versa also. Also, the correction we have here is that the subject can be divided into blocks according to gender, but then within each block, they must randomly assign to be in treatment group or again control group. So this is a simple random sample, very straightforward. We have a population, we randomly pick any item here. The rule is that all the items in the population, they all have the same equal chance of being selected. So again, we select this simple random sample. So we say the random numbers can be generated by a random number table, a software program, or a calculator. Then assign a number to each member of the population. And the member of the population that correspond to these numbers become members of the sample. Then this example, so here we have 731 students currently enrolled in a statistics at your school. You wish to form a sample of 8 students to answer some survey questions. Select the student who belong to the simple random sample. Here we say assign numbers from 1 to 731, since we have 731 students to each student taking statistics. On the hand of random numbers, choose a starting place at random. Then we get second, third, fourth, etc. So this is a random numbers. We read the digit in groups of 3. So here we read a digit in a group of 3. We ignore the numbers greater than 731. Stratified sample means first we have to divide the population into any number of group, and that's what we call the strata. I want to take a population, a sample from a population, but I want the number of female and male should be the same, let's say 50-50. In this case, the best way to do this, use a stratified sample. Our stratas will be the gender. So we divide the group into male, female. Then from there, if we need 50-50 or 10-10, then we take 10 sample from male, 10 sample from female. But this is called stratified sample because first we divide something into 2 or more. So to collect a stratified sample of a number of people who live in West Ridge County household, you could divide the household into socioeconomic levels and then randomly select households from each level. We also have the cluster sample. So the whole concept is clusters. So we divide our population into a clusters. Then we collect our data from each cluster. So here we say divide the population into groups, which is clusters, and now select all of the members in one or more clusters, but not all of the clusters. So here we have example in the West Ridge counting example. You could divide the household into clusters according to zip codes, then select all the household in one or more, but not all zip codes. Then we have a systematic sample. Here we choose a starting value at random, then choose every K member of the population. So example here is in the West Ridge County example, we could assign a different number to each household, then randomly choose a starting number, then select every 100 numbers. So example here, say you are doing a study to determine the opinion of students at your school regarding stem cell research. Identify the sampling techniques used. Here we divide the student population with respect to majors and randomly select and question some students in each major. So this will be again a stratified sampling, stratified. So our stratas will be in this case population, student population. The next, again, we assign each student a number and generate random numbers. We can then question each student whose number is randomly selected. So simple random sample will be the best way. Each sample of the same size has equal chance of being selected. And then each student has an equal chance of being selected. So again, this will be the conclusion of our lecture number 3, which is unit 2 part 3. Again, in these lectures, we do our best to go through an experiment. How do we design experiment? In statistics, it's a very straightforward. Since our experiment will be based on data, the first thing we need to do, again, is to get our data. And then we have to understand the data, do descriptive statistics. We have to make decisions from the data, do inferential statistics. If possible, we visualize our data also. And in the beginning also, we have to go through what we call the data preparation to again understand the data, method of collecting data to avoid biases. We need to discuss all. So again, I wish everybody the best. And again, if you have a question, feel free to send an email. Also, you can reach me at 917-627-0024. Again, thank you.